Hello guys, and welcome back to another geography lesson. Today we're going to continue with the Mapwork section. Now very importantly, before we're going to continue with the section, you need some stationery to continue and be able to do the questions. First of all, you're going to need your protractor, you're going to need your calculator, and you're going to need your ruler. Now the previous lesson we looked at distance and how to calculate distance. Now I need to revise this topic quickly with you because the formulas that we use to calculate distance we're going to use again by determining area and gradient. So if you quickly go to our map of pole, if you want to calculate distance, let's say from spot height 658 to the reservoir over there, what do we need to do? This is a topographical map. We know the scale is 1 to 50,000. And if I want to calculate my answer in kilometers, I take my ruler, I measure the distance between the two areas. It's 17.3 centimeters. And because I want my answer in kilometers, I times it with 0.5. And my answer will be 17.3 times 0.5, and my correct answer will be 8.65 kilometers. If I want my answer in meters, what's going to be different? The centimeters is going to be exactly the same. You measure the distance between the two areas, spot height 658 and the reservoir. So it's 17.3 times 500. And you use your calculator once again. So 17.3 times 500. And you got your answer in meters. So the formula that we use once we work over 1 to 50,000 topographical map, for kilometers is 0.5 and meters is 500. And we also looked at autophotos. Quickly have a look at it in a second. I just want to erase the information over here because we're going to use this map again. Now, once we look at an autophoto, as you can see, it's got a different scale. As you can see, the scale is 1 to 10,000. So the formula that we're going to use is a bit different. So let's say, for instance, we had to measure the distance between 8 and 7. So let's say, for instance, we measure the distance between 8 and 7. It's 11.4 centimeters. So let's just quickly go and calculate it from the autophoto. Autophoto scale is 1 to 10,000. The distance between 7 and 8 was 11.4 centimeters. So what do we do? If I want my answer in meters, I take the 11.4 and I times it with 100. Quickly look at our calculator. 11.4 times 100, and the correct answer is 1140 meters, 1,140 meters. If I want my answer in kilometers, keep in mind the scale is 1 to 10,000. Same principle. Take your centimeters that you measured with your ruler, you times it with 0.1, and just quickly go and calculate it on our calculator. 11.4 times 0.1, and our correct answer is 1.14 kilometers. Now this is very important, and in today's lesson we're going to continue using these formulas to calculate distance. And what we discussed yesterday as well is quite important for me. We looked at direction. Now it doesn't matter what instead of map you use, north will always be on top of the map east on the right hand side, south on the bottom, east on the left hand side. And the simple steps that you need to follow: draw your north-south line, draw a line from where and to. Two simple steps. So if I ask you to determine the direction from the reservoir to spot site 649, so first of all, draw a north-south line, draw a line from where and to, and there's your north, south, and that's probably going to be northwest. Very important to be able to determine your direction. Let's just quickly remove this with the eraser and continue with today's topic. Now, if you quickly look at area is the amount of surface a two-dimensional shape covers. Now, you've done area before in mathematics, and the formula is the length and the breadth. Now, how do we calculate it? We calculate it to find out how much land is covered. It can be because of crop farming, cultivated land such as maize farming, or the calculated land to see what's been built on. Now, if you look at area, first of all, area consists of a formula, length times breadth. In this case, if we quickly continue to the next slide, a couple of steps that we need to go and look at. The first step, measure the length in centimeters and convert it to kilometers or meters. Now, the question will stipulate if they want your answer in square kilometers or in square meters. And your second step, measure the breadth in centimeters and convert it to kilometers or meters. Same procedure as step 1. And then you apply the two to the formula, area equals length times breadth. And lastly, write the answer in square kilometers or square meters. For instance, I'm quickly going to give you an example just from the page over here. Just one another. If I ask you to calculate the area of this block over here, now very importantly, this is your length, this is your breadth, and let's say for instance this square that we see over here is on a 1 to 50,000 map. Now, to get the correct answer in meters, what do we times the measurement with? 500. If I want to get correct measurement for kilometers, I times it with 0.5. So once again, you use your ruler. You can see the length is 19.5 centimeters. If you look at the breadth over here, we measure the breadth over there at 7.5 centimeters. And let's quickly go and do the calculation. Now keep in mind, this area that we measure is on a 1 to 50 topographical map. So first of all, area equals length times breadth. So it's 19.5 centimeters. If I want my answer in square kilometers, what do I times it with? 0.5 times 7.5 times 0.5. Quickly go and use our calculator. 19.5 times 0.5 equals 9.75 times 7.5 times 0.5 equals 3,75. So what we basically just did now, we took our length and times it with 0,5 because we're working off the topographical map. We took our breadth and we times it with 0,5 because we're working off the topographical map. You got your two answers, and now if you look at the formula, you times it with one another, and we're saying 9,75 times 3.75, and the correct answer over here is 36,5. And what will the answer be expressed in? In square kilometers. If the question stated, calculate the area of this block on the topographical map, but give your answer in square meters, what will change? Just the formula that we use when we measure the length and the breadth. So in this case it will be 500 over there and 500 over there, and eventually our answer will be expressed in meters. So let's just quickly calculate it. If the answer was asked for square meters, it's 19.5 times 500. That gives me 9,750 times 7.5 times 500 gives me 3,750. So be times the 9,750 with the 3,750, and we will get an answer of 36,650 square meters. Okay, so that will happen if it's on a topographical map. If we continue to our next slide completely, the question will state, and I'm going to give you two examples and a very popular example of area that's being asked in your final question paper, is to calculate the area of, let's say, this grid situated over there. Now once again, what do you know about area? The formula is length, area. Once again, if you look at the formula of area, it's length times breadth, as you can see. So the question will state, calculate the area of this grid over there. Now first of all, you go and calculate your length. As you can see, it's 9,5 centimeters. Let's just go to the bottom of the page. Area equals length times breadth, and we calculated length. It's 9,5. Because this is a topographical map, what's the formula that we're going to use for meters? 500. What's the formula that we're going to use for kilometers? 0,5. So let's assume they asked a question for square kilometers. So we take the 9,5 times it with 0,5. We go back. We measure the breadth over here. And as you can see, that's 8 centimeters. So it's 8 centimeters times 0,5. If we quickly go back up, just to make 100% sure, you place your ruler alongside the line, and there you can see 8 centimeters of the grid. That's how wide it is. And then we go back to our calculator. First of all, you calculate first your length, and then your breadth, and then you're going to calculate both of them with one another. So 1.5 times 0.5 equals 4.75. And then if we quickly look at how wide it is, 8 centimeters times 0.5, that gives me 4. And once you've calculated length and the breadth with the formula for topographical map, you calculate them with one another. So it's 4.75 times 4, and that gives us 19 square kilometers. So in fact, this whole area where this grid is situated is 19 square kilometers. After the break, we're going to continue with area. Just stay tuned. See you in a bit. Hello guys, and welcome back after the break. Now we've looked at area and we just calculated the area of this grid in square kilometers, and we've got an answer of 19 square kilometers, as you can see on the bottom of the slide. A very popular question regarding area and that they ask you to go and calculate is the area where the autophoto has been covered, as you can see over there. Now I want you to go and have a look on the map that we scanned in and see where this area is. Now the area where the autophoto has been covered is this area over there. So many times they do ask to go and calculate the area that is covered with the autophoto in square kilometer. So basically what you need to go and do, you need to go and calculate your length with your ruler, your breadth with your ruler, but keep in mind, because we're working on a topographical map, you need to times it with 0.5 to get kilometers and 500 to get meters. Now let's just quickly go and do the example on our slide, and I just need some extra space over here to do it. Now hopefully you will be able to do this by yourself by now. If we look at the area covered by the autophoto, let's quickly go and measure this distance over here. Okay, we won't be able to, but let's go to the map quickly and try it from there. So we go and measure the length. Oops, touching with it. As you can see, the length is 10.5 centimeters and the breadth is 8.5 centimeters. So let's quickly go and calculate it. So area equals length times breadth. The length was 10.5 centimeters. Let's presume they asked the answer in square kilometers times 0.5 times 8.5 centimeters times 0.5. Once again, you get your calculator out. 10.5 times 0.5 equals 5.25 centimeters, and then 8.5 times 0.5 equals 4.25, and to calculate your the final answer, it's 5.25 times 4.25, and you get your answer in square kilometers. It's 22.3 square kilometers, and that's your final answer. Now grade 12s, keep in mind, a question can be asked to calculate the area on an autophoto map. Now by now you should know autophoto's got a different scale, 1 to 10,000. If I want our answers in meters, we times it with 100. And if I want my answer in kilometers, we times it with 0.1. Now let's just quickly go and have a look at the example over here. Keep in mind you need to use this formula. Now keep in mind, area's formula doesn't change, but when we go and calculate the centimeters, we're going to use a different formula because we're using a different scale. Now let's just quickly go and have a look at our autophoto. For instance, this area there. Oh, let's just zoom in over here. If you can see this area P situated over there, you can see there's quite a square shape area. situated on an autophoto. Now that can be a recreation area such as a rugby field or soccer field. Now the question might state, go and calculate the area of P in meters or kilometers. Now let's quickly go and calculate the area of P in meters. So we measure the length, as you can see, it's 9 centimeters. We go and measure how wide it is, and as you can see, it's 4.5 centimeters. We said area equals length times breadth. So the length was 9 centimeters. Now remember, the map that we used was the autophoto, and it consists of a different scale, 1 to 10,000. So if I want my answer in meters, I'm going to use 100. So it's 9 times 100. And then we said 4, it's 4.5 centimeters wide times 100. Now let's just quickly go and do the calculation by using our calculator. 9 times 100 gives me 900 times 4.5 times 100 equals 450. And our final calculation to calculate area, 900 times 450 equals 405,000 square meters. And hopefully that will cover area and how to go and calculate area on an autophoto map and a topographical map. Remember that because of the different scale, we use different units to calculate the length and how wide the object or field is. Now, our next topic that I want to discuss with you is gradient. Now, when you think about gradient, we think about the steepness of a slope. We want to see how steep a slope is. Is it the gentle gradient, that's a flat area, or is it the steep gradient, where there's a huge inclination? Now, very importantly, when we look at a map, it's a flat surface. We can't determine the height on the map because it's a flat surface. So what do we use to show us height on the map? The first reference that we use to indicate height is a trick beacon. Now, very importantly, on a trick beacon, there's two numbers, the trick beacon number and the actual height. Now, very importantly, when we show height, that equals altitude, we measure it in meters. Now, for instance, let's say, for instance, we go and climb Kilimanjaro. We don't say the summit of Kilimanjaro is 5.5 kilometers high in altitude. We refer to meters, 5,500, because the unit of kilometers is just too big to use. So we always express altitude in meters. Now, to show us altitude, a trick beacon is the first example I can use. For instance, as you can see over there. Now, very importantly, there's two sets of information with a trick beacon. The 352, it's in bold and printed in italic, is the trick beacon number. It's not the actual height. So the actual height is the 594.5. That means this trick beacon is 594.5 meters above sea level. Please, matrix, don't get confused. The bold italic number is the trick beacon number and not the actual height. If I can use another example quickly on this map. Over there, you can see the bold italic number is trick beacon 162. That's the trick beacon number. and the actual height, the altitude above sea level, is 648.7 meters in altitude. Now, our second reference that we use to represent height is a spot height. Now, we've dealt with them a couple of times when we did calculations, and as you can see, there's a spot height situated over there. It tells us it's 658 meters in altitude. Just to show you another one, there's another one, 591 meters in altitude. Thirdly, that we use is contour lines. Now, contour lines are lines joining places with equal height. If we go quickly to our map, a beautiful example where you can see lots of contour lines is in block A1 and A2. All these brown lines represents lines of altitude, and they are known as contour lines. And what we've learned in the previous lesson, contour lines got an interval of 20 meters. The interval on a topographical map is 20 meters. The interval on an autophoto map is only 5 meters. So all these lines that you see over there in this grid is known as contour lines. Now, lastly, that we usually find to show us height is benchmarks. A benchmark is usually a road that goes through a pass, and next to the road there will be a small sign showing you the height. For instance, 1,400.7 meters above sea level. Now, once we look at gradient, there's a relationship between height and distance. Because what we're trying to establish over here, we want to see how far do we need to travel before the gradient increases. Now, very importantly, coming back to our measurement of gradient and height on a map, as you can see, it's always expressed in meters. Now, my first tip to you, if you calculate distance on a topographical map, you times it with 500. And if you calculate distance to get your answer in meters on an autophoto, you times it with 100. So once we calculate, if you look at gradient, we want to see over which distance does the gradient increases. Now keep this in mind. When we calculate meters on a topographical map, 500, on an autophoto map, 100. Now let's continue looking what the nose tells us. It's a relationship between height and distance. Now, how do we calculate distance in meters? 500 on a topographical map, 100 on an autophoto. Now, the gradient basically tells us how steep it's in a straight line from one area to another area. Now, if you look at the formula of gradient, very importantly, gradient equals the height difference over the distance. The height is the vertical movement from one point to another point, and the distance is between the two areas. How much is the gradient increasing between the one point and another point? So in short, that's our formula. Gradient equals height over distance. And what I usually tell my learners is, it's usually the height difference, because you need to establish what's the difference between the one point and another point. So we need to establish it. But very importantly, when we calculate the difference between X amount and Y amount, what do we need to do? We subtract. It's very simple. We can't go into a minus. For instance, let's say you have 20 apples and I have 25 apples. What's the difference? Only 5. Can't be minus 5. I only need to know the difference between what you have and what I have. So let's say, for instance, you have 55 apples and your friend's got 65 apples. What's the difference between the amount? 10 apples. And keep in mind, we can't go into a minus once we discuss height difference. Now, I'm quickly going to give you an example regarding gradient and how do one go and calculate it. First of all, there's your definition. Formula. The gradient equals the height and the distance. Now, just a tip. How do we express distance with altitude? In meters. Because we calculate gradient, keep in mind, we use the formula for meters. And you know, a 1 to 50,000, to get meters, you times it with 500, and a 1 to 10,000, you times it with 100. Now let's quickly go and look at an example. Let's say, for instance, I ask you, calculate the gradient from tree beacon number 2 to spot height (1,400). Now, grade 12s, be very careful. Tree beacon number 2 means the actual number. Now, if you can remember, it's the bold italic number. So let's assume this is my map down here. Let's continue. This is my topographical map, 1 to 50,000 map. And let's call it the map of Durban. So the question states, calculate the gradient from tree beacon number 2. So I'm going to try and make this bold and italic, a little bit fatter. And the actual height is 2,400 meters. To spot height 1,400. Now, importantly, go and look at your formula. Gradient equals height over distance. But we need to establish the height difference. So first of all, let's just quickly go and draw a formula in here. Let's use a red pen instead. So already we got the height difference. We can establish what's the height difference. And how would you do it? You subtract the highest, the lowest from the highest. So in this case, if we quickly have a look at it, it's 2,400 minus 1,400. So we already established the height difference, the difference in height between the two references that represents height, the tree beacon and the spot height. Now, if you look at the formula, the D represents distance. So you use your ruler and you measure the distance between the tree beacon and the spot height. And as you can see, it's 23.5 centimeters. So 23.5 centimeters. Now we express gradient in meters because the kilometer unit is too big to use. And if you look at our map, it's a Durban map, 1 to 50,000. So what are we going to times it with? 500. So what are we going to do? Quickly get out your calculator. 2,400 subtracting 1,400 equals 1,000. And then what we do, 23.5 times 500 equals 11,750. Now, very importantly, when we calculate gradient, we need to get a ratio of 1 because we want to see how many meters and what distance did the gradient increase by meter. And to get a ratio of 1, we need to divide 1,000 divide by 1,000 because that will give us 1. Now, to get a ratio of 1, what do we do? If we want a ratio of 1, what do we do with a million? We divide a million by a million. If we want a ratio of 1, what do we do? And we got 50 as total. We take the 50, divide by 50, and that gives us 1. So what do we need to do? We need to get a ratio of 1. And what's a simple rule of maths? What you do on the top, you need to do on the bottom. So 1,000 divided by 1,000 give me 1. And then lastly, you say 11,750 divided by 1,000 gives me 11.75. So basically, when we walk from this distance to that distance, it means from there to there. For every 11.75 meters we walk, the gradient increases by 1 meter. So for every 11.75 meters we walk from spot height 1,400 to trick beacon number 2, the gradient increases by a meter. So we need to walk 11.75 meters for the gradient to increase by a meter. Stay tuned, and we're going to continue after the break. Welcome back after the break, guys, and we discussed gradient. Now, I've done an actual example just on the slide, but let's quickly have a look on how you're going to do it on your topographical map. Now, as you can see in front of you, you have a topographical map, and what represents height on the topographical map, we already discussed it. Trick beacons, spot heights. There's a spot height. Let's quickly go down. There's a spot height. Contour lines, the brown lines all over the map, and benchmarks. But let's quickly do an example from an actual topographical map. Now you need to keep in mind, topographical map is 1 to 50,000 is the scale. So we use a calculation regarding that 50,000. So if I'm going to ask you, let's go and calculate the gradient from Trick Beacon 198 to Trick Beacon 196. Now keep in mind, a trick beacon consists of 2 numbers. The bold italic number is the trick beacon number. It's not the actual altitude. It's 156.6 meters. If you look at trick beacon 196, it's 177.1 centimeters. Now let's quickly continue on the bottom of the page. First of all, know your formula. Gradient equals height over distance. So we need to get the height difference between the 2 trick beacons. And our first trick beacon is 177.1. We need to get the difference. So what do? We subtract the lowest from the highest. Like I've explained to you just before the break. You've got 15 apples. I've got 25 apples. What's the difference? We need to get the height difference. So 177.1, if you look over here, subtracting the lowest, 156.6, subtracting 156.6. And secondly, we need to go and calculate the distance between the 2 trick stations. You place your ruler from there up until there. And I get exactly 15 centimeters. Because we express gradient in meters, what do we do with this 15 centimeters? 15 times with 500. If you look at the measurement quickly, from the one trick beacon to another one, you can see it's exactly 15 centimeters from there to there. So now we need to do our calculations. The first one is quite simple. Just subtract the lowest from the highest. Get my calculator out. 177.1 subtracting 156.6, and my correct answer over there is 20.5. We take 15 times 500, that gives me 7,500. Now, remember, before the break, we need to get a ratio of 1. To get a ratio of 1 of 150, we divide 150 by 150. Now, in this case, we need to get a ratio of 1 because we want to see how many meters do we need to travel for the gradient to increase with a single meter. So we say 20.5 divided by 20.5. Simple math. What you do on the top, you need to do on the bottom. So 20.5 divided by 20.5 gives me 1. 7,500 divided by 20.5 gives me 365.8. So that means we need to walk 366 meters for the gradient to increase by a meter. Now, grade 12s, the two examples that I've just done comes from a topographical map. What's going to happen if they're going to ask you the same question to go and calculate the gradient of a autophoto map? Now, I'm going to give you an example. If you look at number 2 over there, unfortunately it's a bit unclear over there. But let's state the question asks you, go and calculate the gradient along the line where number 2 is situated. So let's assume the contour line at number 2 is 1,000 meters. And the contour line on the other side is 400 meters. So I'm quickly going to draw it for you over here. So I've just mentioned, let's try and replicate that diagram, the autophoto. And there was a number 2. And let's say calculate the gradient from contour line that says 1,000 meters to the contour line that says 400 meters. Now, what's going to change over here? Very importantly, grade 12s, we're using an autophoto map with a different scale. Now, the formula stays exactly the same. Gradient equals the height over the distance. Now, to calculate the gradient from the contour line that represents 1,000 meters in altitude to the contour line that represents 400, what do? We subtract the highest from the lowest. And then we go and measure the distance from contour line 1,000 to contour line 400. You place your ruler between the areas. In this case, you can see it's 16 centimeters. But here's the catch. Because we're working off the autophoto, what are we going to times the 16 with? 100. So if we could quickly get our calculator out and do the calculations, 1000 subtracting 400 equals 600. Then 16 times 100 equals 1600. Now remember, we need to get a ratio of 1. So we say 600 divided by 600 gives us a ratio of 1. And what we do on the top, we need to do on the bottom. 1600 divided by 600. Let's quickly go and calculate it. It's 2,6. So that means for every 2,6 meters we walk, the gradient increases by a meter. That's all that we have time for today. Thank you for watching. I hope you've learned something and will be able to do these calculations in your final exam. I'll see you next time around. Thanks for watching.